Welcome to Physics Chapters.
In this video, we will discuss about the last property of dimensional analysis, which is to change one system of units to another system of units. So it means that we can use dimensional analysis to change SI system to CGS system, or CGS system to SI system, or SI system to PS system. Let's see how we do this. We know that we can write any physical quantity like axis of physical quantity, then we have to write this like n and u. Here n is the numerical value and u is the unit of that physical quantity. Like suppose I have a physical quantity velocity and I write velocity like 5 meter per second. So here this is the numerical value and this is the unit of the velocity. Let's take u1 and u2, the unit of physical quantity in two systems, and n1 and n2 are the numerical values of physical quantity for two units. Then n1 u1 is always equal to n2 u2. Let's take A, B and C, the dimensions of physical quantities in mass, length and time. Then we can write this relation as n1 u1, m1 raised to power A, L1 raised to power B and T1 raised to power C is equal to n2 m2 raised to power A, L2 raised to power B and C, T2 raised to power C. m1 L1 T1 and m2 L2 T2 are the units of mass, length and time in two different systems. So we can write here this n2 is equal to n1 m1 raised to power A, L1 raised to power B, T1 raised to power C divided by m2 raised to power A, L2 raised to power B and T2 raised to power C. So this we can write as n1 m1 divided by m2 whole raised to power A, L1 divided by L2 whole raised to power B and T1 divided by T2 whole raised to power C. And this is the relation which we are going to use to find the value of physical quantity in second or new system when its value in first system is known. To get more clarity about it, let me take one example. We have to convert one dyne into Newton. We know the dyne is the CGS unit of force and Newton is SI unit of force. So here we have to convert one dyne into Newton. So we have to find this n2 value here. We know the dimensional formula for force is equal to, we know that the dimensional formula for force is equal to mLT minus 2. Power of m here is 1 and for length it is 1 and for time which is equal to c is equal to negative 2. That one dyne is equal to how many newtons? This we have to find here. So I can write here CGS system. So in CGS system, if we see my n1 is equal to 1, m1 is equal to, in CGS system mass is measured in grams, so 1 gram. L1, the length we measure in centimeters, 1 centimeter, and time T1 is equal to 1 second. Similarly for SI system N2 we have to find M2 is equal to in kgs, 1 kg, and L2 we measure in, length is measured in meter and T1 is equal to 1 second. And here we can write 1 kg is equal to 1000 grams, 1 meter is equal to 100 centimeter and 1 second is always equal to 1 second. Now we'll directly use the formula that n2 is equal to n1 m1 divided by m2 raised to power A, L1 divided by L2 raised to power B and T1 divided by T2 raised to power C. N1 is 1, M1 is 1 G, M2 is equal to 1000 G, L1 is equal to 1 centimeter, L2 is equal to 100 centimeter, T1 is 1 second and T2 is, here it is T2 d2 is also 1 second, so raised to power c. So a, b, c. So here my a is equal to this, d will get cancelled with g, will get 10 raised to power minus 3 raised to power 1, 10 raised to power minus 2 raised to power 1 and 1 raised to power minus 2, which is equal to 1 only. I'm not going to write that. So I'll get here 10 raised to power minus 3 multiplied by 10 raised to power minus 2, which is equal to 10 raised to power minus 3 minus 2 is equal to 10 raised to power minus 5. So we'll put this n2 value here, so which is equal to 10 raised to power minus 5. So the relation is 1 dyne is equal to 10 raised to power minus 5 Newton. If you see, this relation is similar to this, n1 u1 is equal to n2 u2. The numerical value 1 in the system of unit is dyne here, and n2 is equal to 10 raised to power minus 5 and unit is Newton.